Okay, one of the things you're going to want to do really regularly throughout this entire module is you're going to want to prepare before you come to class time. I believe it's been explained that we are using a technique called the flipped classroom. Now, in my own words, the motivation and the reason to do flipped classroom is that, traditionally we have a lecture where the sage on the stage, the person that already knows all this stuff, stands up and talks at you. Maybe there are some opportunities to ask questions. Typically there would be, but basically it's one-way information transfer. And this is all coming at you. Oftentimes it's coming at you cold. You've never heard at least some of this stuff before. And so you're trying to wrap your head around it. And then after class, you're sent off to do some homework. And this is where, you're going to encounter problems, and you're on your own. The sage is no longer there. And, the deadline comes and goes for your homework, and then you're back into the next topic for the next week. Well, the flipped classroom turns that on its ear. And the idea is that you prep and have an introduction to the concepts before you turn up to the first class. This does have a cost. It puts a little bit of effort and onus on you to take responsibility to do that preparation. Oftentimes it could just be watching a video or reading some material. And here we're going to use a combination of both, but there's going to be an emphasis on going through the notes pages for each lecture week after the first week, and running the code yourself to practice and get an idea of what these ideas are. Then in class, we'll spend almost the whole class time, every class time, answering questions, solving problems, and working on the assessment. And so someone will be there, to help you. So this is the sort of idea for the construction of this module. So what we're going to do is have a look at the home page and navigate to the schedule like usual. And you'll see there are a couple of columns here. There's notes, there's code, there's lectures. Now each week there are some lecture slides, but because of the nature of the flipped classroom, we're probably not going to, for any week, give the entire deck of lecture slides. Instead, I'm going to create the habit of going through the notes, and we're going to go over them at a shallow level, and it'll be up to you to revisit these notes every week and practice the codes and concepts. In fact, I recommend that you, just like I will demonstrate, open the sandbox and run every line of code yourself, including typing it. I'm not going to be able to force you to refrain from copying and pasting. And if you get frustrated, or it's just going faster if you copy and paste, you probably will. But you will learn a lot more by typing it yourself in real files, saving those files in your sandbox, and making your own mistakes and figuring out what those mistakes are and correcting them. You'll learn much faster. And if you do that from the beginning, the habits that you'll pick up so quickly will carry you very, very far later into this module, and it will impact your success in all of the other modules in this whole course. So that's my advice. What we're going to do this week is we're going to start on week 2. This is where we're introducing the C programming language, and just look at the notes. Okay, now the notes are very structured. I hope you find them to be very well organized. Put a lot of effort into curating the topics that are covered and touched on in the lecture. I'm just going to go through these and code when appropriate. And, we started off last week. You had an introduction to Scratch. It's a visual programming language, but the concepts of programming are exactly the same for Scratch as they are any other language. And the idea of functions, the idea of conditionals, the idea of loops, the idea of variables, they're all in there. And that's what we're going to essentially go over today in the forms they appear in the C programming language. Now, if you watched my tutorial on the on the Linux operating system and those terminal commands, I've already mentioned C in that, but we'll go through how the system works. We're going to be using C for several weeks in here. If I go back in time, I have to say that C is probably the most impactful language for making computers do the work we want them to do for us than any other language. It's still in wide use. It's extremely fast. I prefer personally to code in Python. Python is a higher level language. The syntax for Python is newer, and yet my first class in formal programming instruction was in C as a student, and I still have nostalgia, and I still recognize the importance of C. C is many, many times faster than Python for doing many things, and it's a valuable tool to learn. It'll give you a lot of insight and make you a stronger programmer no matter what computer language that you use. Okay, so moving along, we're going to look at Visual Studio Code. We've already introduced that a little bit. We're just going to look at it and look at the structure of the interface. I've already opened my sandbox here. I've already demonstrated that, and it's been demonstrated to you, and I know many of you, maybe all of you, I hope, have already logged into the sandbox at least once. I judge that from seeing the repos that you've saved. Now, instantly, we're confronted with a number of windows here. We have some frames over here. First thing I'm going to mention is this pane on the left. And there are a number of tabs that we can click on. The top tab is the one that is the default to open, and it's the Explorer, and it gives us a file explorer to the folders and files that are in our root directory for our repository. Well, here we can see there are a couple of hidden folders. We know they're hidden because they have dot in the front of their name. That generally means you shouldn't mess with those. In fact, if you do mess with them, it will break your sandbox, and if you can't put them back, you won't be able to access it anymore if you tamper with them too much. So I would leave those alone and just pretend they're not there for all of the assessment links as well. These other files that are here, there should always be a README in the repos for this Google Classroom, for the ones that I have created for you, for the assessments and for the sandbox. And usually that gives a little bit of intending to be helpful instructions about what the environment does, what it can be used for, and so forth. And I've given a couple of other little files here by default. I've given you a starter hello.c program, which is covered in these notes that we're going through. A make file, which essentially updates a command line operation when you use the command make. I'll demonstrate that pretty directly, and I'll explain what clang is. But you should never edit this or have to edit it. It's just present in the environment for you to use, and it just makes it where you type less when you're compiling C programs, which I will also explain. And then we have a Playground IPython notebook. We won't be using these in this class very much, but for the sandbox a little bit later on when we do start Python, even though we'll be using the command line, if you've used IPython notebooks before, feel free. You can make as many as you want to play with, and you can experiment with this. And if there are any questions or curiosity in class time about it, we can demonstrate it and explain what it's for when we get to Python. Okay, so the tabs on the left, the ones that you'll typically use most of the time, we're not going to go through all of these, but there's a search. You can search any and every file for keywords or phrases in your whole repo. When we've already talked about the source control button as well in some of the other videos, if you've watched them, where this connects to your GitHub repository attached to this particular workspace. So you'll have, a different repo for the sandbox, and you'll have one for every week of assignments. And you'll have to access those through the respective links on the assignment pages. These other ones are more specialized. There's a debugger, which we won't cover in this course, but it you develop big programs, large programs, sometimes helps to find where errors are and what's happening. But we may cover that in a future course. There's this little set of building blocks, which are a set of plugins called extensions for VS Code. Some of them are installed by default for you. There are many, many of them. If you're comfortable doing this and you rely on some extensions, feel free to install them. You would have to install them for every repo, I believe. And, if they don't, you'll do fine in this course. We've gone to great lengths to make it as easy as possible for you to ramp up and get confident at using them. And we will use these in other modules. There's a testing pane, which we also won't touch on in this. It's to monitor built-in tests for specifically for Python. And there's a GitHub repo page that has some extra functionality to the source control page. But we're going to stick to source control. All the examples and demonstrations we'll do will be just using the source control pane. All right, that covers that one. We generally have a space here in the middle top that is for where our files are open, and we can interact with them in the graphical user interface. We can close the tabs. You can double click to open the new tab. If you single click, if it's the same kind of file, it often will just replace the tab, or else if it's different, it'll open a new tab. Down here is the terminal, and there are different tabs, but the one we will mainly use for our work and for these demonstrations in this module is the terminal. If you haven't experienced the terminal before, we'll briefly go over it in this tutorial. And over here is I've left it open just to show you. It is possible to chat with GitHub Copilot. Now, we have some rudimentary access to this AI coding module in here. You can close it if you want to reclaim your space on your desktop. The way we can close it is just to click there, and we can open it again by, well, usually there it is. So we can open it again with this little drop-down menu. So, I'm not going to cover the issues again and the guidelines for using AI in your report. Let me just say that AI is fun. I use it every day. I hope you guys use it every day. It's been the most fun and rewarding period of my entire career in the last couple of years, as I've learned about how to use AI to make myself more efficient. But AI will not replace the basic knowledge to really use it powerfully. Any dummy can use it in a low level way, and any dummy can use AI to produce the code for very simple programs, exactly like the kinds we're going to be working on in this course. But if you do anything more complex, if you ever aspire to do something someone will pay you for, you're going to have to know the basics, because you have to know the basics to be able to articulate the context and the prompts for an AI to really do real work that's valuable for you. And let me urge you not to abuse the AI. Stick to our guidelines, learn this stuff, put the time in. It will pay off, and it will start paying off so fast. If you rely on AI, you're going to struggle. You're going to hit a wall. So that's my advice to you. Okay. I think that's all the simple outline of the environment I want to go. We talked about our hello world. Now, if you go through this code, and I urge you to, and type in every word yourself, one of the things I want to demonstrate to you right here is how to actually produce the code for hello.c, to compile it with the make command, and to run your executable with the //. All right, so it turns out we've already got a hello.c right here, which we've looked at before. I'm just going to do something really cheap. I'm going to copy my hello.c program. I'm going to make a directory called notes week 2. Let's see if it let me spell notes correctly. I somehow misspelled that very incorrectly. Yeah, it won't let me recursively. Let me see if I can use the flag R to do it. I'm just doing a little experiment. No, it doesn't like that. So I'm going to make a notes directory, and then I'm going to cd change directory into notes. Then I'm going to make a week 2 directory. Oops. And then I'm going to cd into week 2. Sorry about the noise of my clicky keyboard. I've changed my microphone position and I can't get the noise gate to do it out with the volume I like on my voice, so I'm gonna have to deal with that for now. So now what do we have? We have an empty notes directory with a week 2 inside it. What am I going to do? Well, if I look at what we're doing here, the first thing I'm going to do is introduce this terminal command called code. And if we just execute that, what it does is it creates a folder in the present working directory, a file by the name you specify with nothing in it. Remember, I cheated and I copied. This is just for the interest of time. I also want to point out the basic structure of this program. I'm just going to make it a little bigger for your behalf. Maybe even a bit bigger than that if it doesn't look too stupid. There we go. That looks better. What this does is it adds in functionality from a so-called header file that's built in to the environment that you've opened with access to this header file. And the syntax we use is hash signed or pound include, and then in brackets, in perpendicular brackets, cs50.h and stdio. For many C programs, we're going to have stdio. This is standard in and output, and it's one of the very commonest headers to include in any C program. The CS50 one has got some some functions in it that you will probably find useful. In fact, you will probably heavily rely on them for all of the assessments. And they're just ones that I've moused over there that you can see, get string and a few other utility functions, which we'll demonstrate as part of this, maybe as part of this notes tutorial. Okay, and here we've got a a main body of the program declared, what type the body is. It's an int, an integer, and then the input is void. So when we run it, it doesn't require input to go in. We'll talk about this in just a little bit more in just a second. And what is it doing here? It's declaring a variable. We need a string, and we are going to call that variable name, and name is going to use one of the CS50 functions, getString. So we're going to prompt the user at the terminal, what's your name? And they're going to put in their name in the box and hit enter, and then they're going to print this sentence, welcome to the Statistics Lab sandbox. The %s is a symbolic representation of a string variable. The S stands for string, and then a new line return. And then there's a comma, and the last bit of the argument that's passed to this printf function is the name of the variable that's referenced by %s. So we've passed the name variable. So we're going to grab the user's input of their own name, and then we're going to print welcome to the Stats Lab to that user input. Okay, So what I'm going to do is, and the code command, by the way, all it does is it creates a new file and it opens it for you to immediately make changes to. It's just a total convenience. You get addicted to using it. It's so easy and so much faster than going through the graphical user interface. So check that out and try it. So I'm going to save this, and we don't have to close it, but we can close it. In fact, we can close everything we don't need. I'm just going to make this a little bit bigger. If I clear, so we're a little easier to see. What we're going to do first is we're going to make hello.c. And I forgot that we don't need to specify the .c. So yes, indeed, I did mean make hello. Now it's thinking. And what we've got is a compiled hello file. Now this will be ones and zeros. The .c is for us. It's got human language in the form of C syntax. And the hello file is a compiled program that's executable that will run our instructions. It's written in binary code that the computer can understand. So to run that, I'm just going to click in the terminal. By the way, if you click out of the terminal and you don't have the cursor highlighted, sometimes that can be a bit confusing. So you have to click into the terminal if you've clicked out in order to use it. We're going to type /hello, and it asks me what's my name. My name's Ed. Welcome to the Statistics Sandbox, Ed. Excuse me, I have the hiccups. That's just a little demonstration of what we're doing here. And, you know, what's going on there? Well, we have this model. If I just scroll down a little bit, I don't have the symbolic image here, so maybe I'll just draw it on this on this page. Get my pencil ready. There we go. And use a purple. Maybe I'll use a red. There we go. Test it. Nope, still black. Save. Okay. There we go. That's what I want. So I'm going to close that. All right. So, you know, what we've got here is we've asked the compiler to take some input, put it in a box, which becomes our compiled program, and then produce some output per our instructions. This is exactly the same model, exactly the same schematic you recall that we talked about in the Scratch introduction. So I urge you to practice with these programs and build them up yourself. You can go through this code yourself. The program that we ran is under the Hello You header. This is the one we just wrote. Note that all of these programs, this is a good practice to get into. They have a comment. The symbolic syntax for adding a comment is the // and everything after it on that string is a comment. And you can run strings across different lines with a different syntax. You can use this sort of syntax with an asterisk to have stuff that goes multiple lines, and then enclose it with another asterisk / if you want to. if you need to, but it's good practice to put in some comments. I'm not going to emphasize that just now, but we'll come back to that. Talked about the string symbolic character to represent in a printf statement some variable. But C is a kind of programming language that forces you to explicitly declare what type of variable you're going to be using. So it could be a character or a string that are similar. Could be a floating point number. That's just a number with a decimal point on it. Could be an integer. Could be a long integer, li. Could be a long integer. There are several others. These are just the basics of a few of them. We'll use some of them in the assessments, and you can practice and read about those on the manual pages if you're interested. One of the things that we're going to work on is conditionals. That's going to be an important part of the assessments this week. And what we do when we use conditionals is we are going to assess oftentimes whether some condition is true or false. If I just make this a little bit bigger for your behalf. There we go, that's better. We can see that the conditional here is x less than y. Well, we would have to have variables declared to contain some value for x and some value for y to be able to use this. But we can evaluate this. If x is 10 and y is 5, let's just say that's the way the world works for this. Then the expression is 10 less than 5 evaluates to false. So this is true and false values, or so-called Boolean expressions. Zeros and ones are true and false. And there are different ways to represent them in computer programs. Here, if this expression is true, we would print this line. And if it's not true, we would print this line. And so for this case, we would print, x is not less than y. We'd have to have the input, some way to ascribe those values, but that's how they work. And there are different kinds of ways that we implement conditionals routinely in computer programming. If I just turn that off. We'll look at a few examples in a sec. But first we're going to look at operators. How do we do basic math with computers? Well, just like a calculator, we can use plus, minus, asterisk for multiplication, / for division, 1% sign for remainder, and there are others. But these are ones that we use relatively frequently. How do we declare a variable? This is one of the real basics. Oftentimes, we will declare a variable, and as I mentioned in C, we have to do that explicitly and tell the computer what kind of variable. Why do we have to tell it what kind of variable? Well, one of the main reasons is that the type of variable we declare determines how much memory the program ascribes to the storage of values that variable could possibly contain. And the name of the variable, in this case it's counter, is is one that, oftentimes we refer to these variables, these containers or boxes that we store some value in. You can even think of them as physical addresses in memory, where here, we store a 0 in that box or that little house on the street in a vector of data, or this is just a single data point. Oftentimes we refer to these as random variables. And they're referred to as random. Doesn't really make that much sense in English, in the English language, but they're called random variables for the fact that they can actually take on any value within the constraints of the type that we ascribe to it when we define it, when we declare it to exist and carve out memory for it on behalf of our declaration. We could actually assign any value we want to that variable name. And, we could randomly assign it. We don't literally randomly assign it. In fact, far from it. We don't want random numbers ascribed to our variables. Instead, we might want something systematic to happen. Like we might want a counter variable to increment by 1 and go through some steps where every time it's incremented by 1. This is a very common scenario for loops, which we'll come to in a moment. So for this, every time this line is called, every time it appears in your program, we would take the existing value of counter and set it equal to the existing value of counter plus 1. That's not good enough for computer scientists. Computer scientists are notoriously lazy, and this sentence right here is long. It takes so much effort to type that. Who can be bothered? So a little trick is you can use a special operator called plus equals. It occurs in minus equals as well, where this is shorthand for saying counter equals counter plus 1. Counter plus equals 1 is exactly the same. But wait, we can do better than that, because if we just want to counter, again, remember I mentioned this is the reason there are several special cases here, is that this is really one of the commonest types of operator operations, and having a counter variable is present in many, many kinds of programs. We can just use plus plus. Notice that there's no space in between the name and the plus plus. And of course, minus minus, in fact, minus works with all of these examples. Okay, so what can we do with this? Well, we can write a little program. This one's called compare.c. Again, for the interest of time, I'm just going to copy that, but I urge you not to copy it. So I'm going to make that. I'm going to type in the code. I'm just going to make this a little smaller so we can actually see all the code all at once. We've got the same CS50 header because we're going to go get int. I'd probably go ahead and recommend that you get into the habit. It's a very good habit. In fact, if we have to go inside your assessments, your problem sets, which we will spot check all of them, even if they get full points. One of the elements of style we'll be looking for is whether you've included comments. For me, I'm just going to put this. What these forward slashes do, I call them comment syntax, but what they really do is prompt the compiler to ignore any lines that start with // I explained the standard I/O. That's the one that contains the printf function we'll use a lot. And here, if we compile and make this, what we're going to do is we're going to see, well, let's see what it does if we just do it. I'm going to save that. I'm going to go make. We get our compare. What's x from our get int? Say that it's 5. What's y? Y is 10. X is less than y. So it's, very simple. It's trivial. Nobody would ever write a program like this. The idea is to use this kind of logic as a building block to something that is interesting. Now, there are several examples here. I'm going to let you go through these on your own. This one looks at whether the user inputs a character string. So the main difference here is whether there's a character string and whether the input exactly matches your options. Try to break this. Try an S. Try a capital Y. See what happens. Loops. You're going to want to spend some quality time developing loops. You'll definitely need to for your assessments. Is one way we can do the same operation over and over is we could create a program that prints the same thing 3 times. Print meow, meow, meow. And, just to put a point on it. We can I made a typo there. You notice the period, not the dot, and it gave me a little error. There we go. So we get meow, meow, meow. So this is kind of a dumb way to do it. You want to avoid doing this. What if you had 1,000 meows or something more interesting than meow that you needed to repeatedly do and maybe update with a different variable value? This kind of operation is very common, and it's very poor form to just hard arm it and do the same code over and over again. Makes your code very difficult to read too. In this trivial example, it's not a big deal, but you can imagine that it gets done. Instead, here we might use a while loop. Here we have set an integer to the name of a random variable called I, and we've set it I to 3. And it says while I is greater than 0, print meow. And then inside the curly braces, we've got I minus minus. So I starts off at 3 the first time it prints a meow. Then it increments I to 2. Then it evaluates while I is greater than 0. Is 2 greater than 0? Yes, it is. So we're going to evaluate this again, print meow. Then we're going to decrement I from 2 to 1. While I is greater than 0, 1 is greater than 0, so it's going to print it a third time. Then it's going to decrement I. 1 minus 0 is 0. Then it's going to implement, it's going to evaluate 0 greater than 0. No, it's not. So it's not going to do anything else, and the program will terminate. So we can just demonstrate that. I'm not going to make a new file for this. Instead, I'm going to recycle it. I'm going to recycle my make meow. I'm going to recycle my run meow, and we get exactly the same output with our new program. Now we're going to go through a couple of these kinds of loops, and I'm going to leave the other ones for you to play with. This is I looking at a different evaluation, starting with I at 1. Is it less than or equal to 3? You can demonstrate yourself that what comes out of there, is it the same? Here's int starts with 0, and it's whether it's less than 3 plus plus. And finally, we're going to demonstrate a for loop. For loops are one of the real bread and butter functions. The way that they are different, the while, is you set limits explicitly in the beginning and end. For loops are a real staple in all computer programming languages. So here we specify the argument for int I equals 0. An advantage here over the while is we declare the variable right inside the function as an argument. And then we're going to evaluate whether I is less than 3. So that's our evaluation statement. And then we're going to increment, in this case, I++. So this saves us a line down here. This makes for cleaner code than while loops. There are some situations where you might prefer one or the other, but we're learning the basics right now. Now, functions. This is one of the building blocks. We've already used quite a lot of functions, like the printf function. But here we're declaring our own function. What kind of function is this? Well, it doesn't have an input, so we're declaring it as a void. It's absent of having a type. If it's going to, we'll talk about other situations in the future, but we would give it a name and we would give it an input. And in this case, no input, no argument is required for this function. It's so simple, and all it does is print meow once. Well, the way that we might do this in the meow program is we would include our standard IO header for the print function. We would declare our function. Now, let's make a distinction here. This is a pretty important concept. It's confusing the first time you hear about this. At the very top of your program, right by the header, we have to declare any custom functions we've defined. And you can put this in various places in your program, but you have to define the function you declare at the top in your program. And so this is the definition that we just talked about of the function called meow. And or this is rather. And traditionally we put it at the end of our actual program code. Traditionally we put it at the end, just like this is done. And then our program, we've created a main function. This is the same kind of main function that we've created before. We've included our for loop, but now instead of explicitly using our printf, we're calling our own custom function, meow. Now this is again a basic example, even a trivial example, but it's one that you'll use over and over again. And when you get into more complex programs, you will see how useful this is. Okay. Now, just this concept, this is directly applicable for your assessment. We can evaluate code on 3 axes, and we will do to assign grades for your work. Now, one is correctness. The auto grader in those GitHub repos only look at correctness. The design aspect is, are there design aspects of the code? Have you used loops where you can to avoid replicating identical code would be a good example. And style refers to how aesthetically pleasing and consistent is your code. Style is one that AI falls down on radically. It's not very good. I've had the luxury for the past 12 months of using AI to work on complex projects almost every day. And a thing that I've spent so much time on is how to make reproducible, stylistically consistent code. AI is not very good at that, even with expert prompting. So we will manually look at design and style in your assessments, but keep an ear out to them. We'll be very gentle with our eye to them, but keep an eye open for that. And it's a thing that you'll learn as you go along. Now, we're going to cover the details of the actual assessments in class. And so the first one that we're doing is a little exercise to print to print some things in the theme of Mario Brothers, the video game, the famous video game from Nintendo. And we're going to practice in the notes here with a few trivial examples to create ASCII structures that are graphically similar to real structures in the Mario video game. I'm going to let you run through these on your own. So there are several examples of horizontal blocks, vertical blocks, a thick vertical block we'll call a grid, and then you'll make something a little more ambitious for your first assessment. So it's very important to run through this code and give yourself time to understand what's going on here. I mentioned comments. They are very important for computer programs. What we do is we're writing our code. I'm only going to say this verbally. It doesn't actually say it in this particular way in the notes, but they have to be present, basically, to hit that style mark. And you can lose a point if you don't have any comments in any of your programs for the assessments. You must remember to write some minimal comments in there that are brief, that describe what the function, what the parts of your different code does. And the longer your program is, potentially the more comments you might have. Now there's only one comment in this one, but we could actually put some more comments to talk about the function definition, the function declaration, and the main body of our program. This is a thing that you want to develop your own consistent style for. You're writing these comments not for yourself, although they are useful to you if you drop a program, if it's more than a few tens of lines long and you don't look at it for some while, much less if it's 100 or even 1,000 lines long, you're going to forget what code you wrote. So those comments should be a roadmap. Here's exactly why I wrote this. Here's what it does. Here's exactly why I wrote this one. This is what it does. And my personal rule is I write comments in my programs to someone else. I imagine I'm writing it to some person I've never spoken to about the code, someone who's very important and who I have a lot of respect for. And so I don't want to, you don't want to skimp on the comments. It's so easy to add them, and they're very useful. They're an essential part of good style. It's a little exercise for you to investigate more about operators here. And there's a little exercise to learn about truncation. Now, to sum up, what we've covered is how to create your first program in C. I've demonstrated that. How to use the command line. I've demonstrated that. How to predefine functions. We've talked about that several times. How to use variables, conditions, and loops. We've talked about that through different sections, and there are plenty of exercises for you to go through. How to create your own functions is part of using functions, the predefined ones. How to evaluate your code using the ideas of correctness, design, and style. And I explained that the autograder will give you feedback only on correctness, but you may receive additional feedback on design and style. How to integrate comments in your code, very important, and how to utilize types and operators. That's it. Run this code yourself, and that's all I have to say about this.